the very slow, sad $5 Singer sewing machine is getting an upgrade. So, I cleaned up the pedal, took it apart, scrubbed all the contacts, got a bunch of gunk out of there. I also took the motor apart, cleaned up the brushes in there and the commutator, and put it all back together, and it's actually running now. It would spin the motor without any load on it before, but it wouldn't drive the actual machine. So now it's able to drive the machine, and here I have the ultimate test. This is 4 layers of, that's probably like 2.5 millimeter thick leather. I don't know, it's probably like a weight designation or whatever. But anyway, 4 layers of leather here, and I'm just gonna rotate it up so that it can start out of the leather, and then I'm pushing down. So that's 4 layers, chucking away. No problem. So, I bought this motor. I thought I had done some research. It is out of it actually doesn't have any numbers on it, but it's out of a Singer 626, according to the eBay listing. And I had done some research that said, and found that apparently a Singer 620 motor is bigger. It's I think these are both 70 watt motors, and the 620 is a 120 or something watt motor. I could be wrong about that. But anyway, I saw some research saying that a 620 was a bigger motor. And I saw 626. It was from the same line of sewing machines. And I knew that, you know, the geometry and stuff was the same. And apparently they're all interchangeable. So I thought, oh, great. This motor is probably bigger than the one on it. Well, it's not. So I pulled this all apart. I pulled this one apart. As far as I can tell, the windings are exactly the same. The rotor is the same size. Everything measures the same resistance. It's like 60 ohms roughly for each motor. The bearings are the same size. As far as I can tell, this is the exact same motor. It's just repackaged in a different housing with like a longer snout on it. So that kind of sucks, because now my bigger motor upgrade for the sewing machine isn't necessarily a bigger motor. However, I'm an engineer. That's like my job, is to make random mechanical shit. So I made this random mechanically bit. And this random mechanically bit, so there's 2 screws there. That's what mounts the motor. So I'm gonna get some longer screws. I'm gonna go through those 2 holes. That guy mounts there, like so. So can you guess where that's going? Huh? Hang on. Da-da-da-da. So I need hardware to mount that, but that guy mounts there. It gets clamped in. I need to obviously make that gear not a gear, so I need to make a pulley. That should be pretty simple. I definitely won't do it on the lathe at work, because that's definitely not allowed. Absolutely not. I would never do anything like that. So yeah, now instead of a 70 watt motor, I have a 140 watt motor. So that's what I'm doing right now. I'm just wiring up this. This motor actually came with a bunch of wiring and an extra light. I don't know if I'll use this. Maybe. We'll see. And a switch. I may end up using this. I kind of like this. Although this light won't actually fit. But I kind of like this, like, the switch style on this guy. I don't know. It's really cool. It's really positive. Anyway. Yeah, it came with a bunch of wiring, which is kind of nice. So I have these connectors, and they go onto these. It's like a bullet connector. It connects onto this motor, and I've wired that through, and I basically wired these 2 motors in parallel. And this coming out here is going to go to the pedal. So the next step is a pedal. This is the pedal out of that original sewing machine. I kind of think that this was actually part of the problem and the reason it was so slow. This is like a very old-fashioned, I think it's called a rheostat. It's basically a variable resistor, but it doesn't do much variableness. Maybe I can show you that. It basically has off and on, and not much in between. So you either get full power or no power. Alrighty, excuse the mess. So I got my pedal hooked up, and then some multimeter leads jammed in the end of that. And so right now, pedal's off, and you can see that by there's effectively infinite resistance, so this is an open circuit. Now when I slowly push down on the pedal, oh, something happened. So something makes contact and we get 120 ohms. And now I'm pushing down, I'm pushing down, I'm pushing down, I'm pushing down. Oh, sorry. And now it's 0. So we go from like 120 ohms on the top end to like maybe 100 and then 0. So you get off, completely useless in the middle, and then full bore. So I think my next step is to like go finish packing and leave for Christmas. But then when I get back, or maybe while I'm at home for Christmas, I'm going to order a new pedal. That is, you can get new pedals that are electronic. So they have, I assume, like a brain box in them that varies the current or resistance or something, but like slightly smarter than the way this does it. And so you get a better control. You get better control over the motor, basically. Better control over the amount of current going into the motor, which controls how fast it moves, sort of, roughly. So, I hope that wasn't too incoherent. Maybe eventually in the next 2 weeks or month or whatever, I'll get the parts needed to make this run. I would like to eventually get this up and running and do heavier duty stuff. So I have this, leather jacket would be a fun project. I need to replace the zipper in it. I have another machine, a Kenmore, that was given to me. It's definitely lighter duty. It complains when it gets thick stuff. It could probably do this actually, no problem. But I'd like to eventually make, maybe some stuff for my car or more utilitarian stuff. So that's sort of the goal of this. Hope you liked it. Merry Christmas.